Hello students, so here I am with a new chapter, that is Archimedes principle. In my previous online class we have come across pressure in fluid. That means whether it be gas or liquid, all exerts pressure. Now you see in your screen you can see that I have taken a two vessel. You can consider vessel A and vessel B, right? In vessel A I'm trying to push a can or immerse a can inside the water. While doing so, I experience a force in the upward direction. That means the can tries to come up. This upward force is considered to be as upthrust. Okay, so the upward force exerted on a substance or on a body when it is partially or fully immersed in a liquid is called upthrust. So here you see upthrust is denoted by FB, right? B is in superscript. The upward force experienced by a body when partly or wholly immersed in a fluid is called upthrust, or it is also called buoyant force. So buoyant force not only we see in case of immersing an object in a liquid, but similarly when a body is made to fall from a certain height due to air friction, the object floats in air for few minutes or for few seconds. So due to air friction, so there is a upward drag force, so that is also due to buoyancy, we can say, right? So here buoyancy we will be discussing all about liquid, that means buoyant force exerted by a liquid when an object is immersed in it. So the unit of upthrust is dyne in CGS unit and Newton in SI unit, right? Because upthrust is a force, so SI unit of force is Newton and CGS unit is dyne, right? And GF and KGF, that means gram of force and kilogram of force, are gravitational units in CGS and SI unit. Okay, so different cases of buoyancy. Now you see, so buoyancy can be experienced in three possible cases. First case is saying that when the weight of a body is more than the liquid displaced by the body. In that case, it has been seen that upward force becomes maximum. Like if I take one vessel and this is the liquid level, now when I am immersing an object inside the liquid, if the weight of this liquid is more than the liquid displaced, therefore the liquid or the object will sink down. Or you can say, if the density of this object is more than the density of the liquid, then we say that object will sink inside. In the next case, we see that if the weight of the object is equal to the weight of the liquid displaced by the body, in this case resultant force is 0, hence the body remains floating. So an object will float if its weight is being balanced by the upward force. An object will sink inside if its weight is more than the upward force. And in the third case, an object will float above the water if the upward force is more than that of weight of the substance or weight of the body, right? Like for example, thermocol, when it is made to keep on the top surface of a liquid, it seems to float because in this case the weight of the thermocol is less than the upward force exerted by the liquid, hence it flowed and it rises up. So there are few characteristics of upthrust. That means if you are dipping, here in this case in the diagram you can see, if the can is very big, then it will exert more upward force. If the can is very small, it will exert less upward force. So these are the properties. So larger the volume of the body submerged in a fluid, greater is the upthrust. Larger the density of the liquid, greater is the upthrust. That means if you are immersing an object in a liquid, in case of water, let us consider water. So what amount of force is exerted by water on that body will be less than the mercury exerting on that object. Means same substance or same body, if you immerse in water as well as in mercury, so mercury will exert more upthrust as compared to water because the density of mercury is more. So here you can see in this paragraph, this is the reason that an iron nail floats in mercury but it sinks in water, because the density of mercury is 13.6 times greater than that of water. Okay, but for same volume the upthrust provided in mercury is much greater than provided by the water. If you take same volume of water, if you take same volume of mercury, but in that case mercury will exert more upward force. Next property we have, larger is the value of G, larger is the upthrust. That means this upthrust depends upon acceleration due to gravity also, that is small g. If the value of G is very small, or if you consider 0, so upthrust will be 0. So in a place where G is very high, like in a surface of the earth, so it will be maximum. Again, G is inversely proportional to distance. The more height you go, so less will be the G. Similarly, more depth you will go, G will also decrease. And whereas upthrust also depends upon small g. So these are the three factors upon which upthrust depends, right? Characteristic. Next you see in your screen, you can see one beaker. Beaker is containing water and a cylindrical object is immersed in it. So let us consider it is at a distance of h1 from the surface of the liquid, and it is at a distance of h2, the lower portion of that cylindrical body height is h2 from the surface of the liquid, right? So here we will prove that upthrust exerted by the object is equal to the weight of the liquid displaced. That means more the liquid above that object, more will be the upthrust. That means if you immerse partially, if any beaker is there, if the liquid level is this one, now if you immerse your substance up to here, and in the next vessel same liquid level, if you immerse the object deeply, then in this case upthrust will be more, in this case upthrust will be less, right? So therefore the same we will be proving in terms of expression. So let us consider pressure exerted on the top surface, that is h rho g, that means h1 rho g. H1 is the height from the surface, and pressure on the lower surface, that is h2 rho g. Now you see the pressure exerted on the lower portion is greater than the pressure exerted on the top portion, always, right? Because the weight of the water is maximum in the lower portion, and from the top portion to the surface the less amount of water is there, the weight of the liquid is less. So therefore the pressure exerted on the lower portion here, this will be more than that the pressure exerted at the top portion. So therefore downward thrust on the upper surface, that is AB, that means first. So what is the downward thrust? We know pressure equals to force per unit area, right? So force will be pressure into area. So how much is the pressure here? H1 rho g, and area is A. So we get an expression, that is downward upthrust A H1 rho g. Upward thrust will be again P into A. P is H2 rho g, and A, that means A H2 rho g. So just now I told the force exerted on the upward direction is more than the force exerted downwards, right? So that as H2 is greater than H1, so therefore A H2 rho g. So here you can say F2 minus F1. So F means P into A, P is H2 rho g into A, that means A H2 rho g, and minus A H1 rho g. So taking A rho g common, where rho is the density, okay, rho is the density of the liquid. H2 minus H1, H2 minus H1. Now you see A and H, unit of area is meter square and unit of height is meter. So meter into meter square is meter cube. So meter cube is volume, right? So therefore A H2 minus H1 is considered as volume, that means V rho g. Okay, so once we get V rho g, again you see V rho means mass by volume, rho means density here, that's why mass by volume, into g. So V and V got cancelled, so what we got? mg. So therefore upthrust equals to mg. So more the weight of the object, more of the weight of the liquid displaced in upward direction, or more the weight of that body immersed in the liquid, more will be the upthrust. So this is the proof, right? The upthrust experienced by a body when it is immersed in a liquid is equal to the weight of the liquid displaced by the body. So more the object, more the liquid is displaced in upward direction, more will be the upthrust. So what are the causes of upthrust? You see, when an object is immersed in a liquid, it exerts or it experiences a lateral pressure, that means pressure due to walls of the container, right? So now lateral pressure cancels out each other. That means if I consider this is FA and this is FB, so FA equals to FB, so they will cancel out each other. But you see, the pressure which is exerting in lower and upper half is not balancing. So we say that pressure exerted in the lower surface is more than the pressure exerted on the upward surface. So this causes the upward push. Okay, so this causes the upthrust. So in this paragraph, when you're going through the book, you will find the pressure in this paragraph. You see the pressure acting upward on the lower surface of the body is more than that acting downward on the upper surface of the body due to its greater depth. So due to its greater depth, the pressure exerted on the lower surface of the body is more than the pressure exerted on the upper surface of the body due to its greater depth. Hence there is net upward pressure acting on the body, and therefore if pressure is more, force will be more. So therefore force is always acting in upward direction when object is immersed in it. When an object is immersed in a liquid, its weight get decreased. That means there is a loss of weight. This loss of weight is called apparent weight, right? So weight of a body at a given place does not change. Means if you are in air, if you are on the same surface, the weight remains same. But as soon as you are immersed in a liquid, or as soon as you immerse a body in a liquid, its weight decreases. This loss of weight is given by actual weight minus upthrust. Now if the upthrust exerted by the liquid will be more, then you will feel more lighter. If the upthrust exerted by the liquid is less, then you will feel weight. Okay, so that is why if you are inside, if you have experienced, if you carry a stone and you are inside the water, so you will find the weight of the stone is lighter, but same stone when you try to pick it up in air, you'll find it is very heavy. So in this case it states that here water applies an upward force. Due to water applying an upward force, you seem, or in the object seems to be lighter. So Archimedes principle is based upon upthrust. Okay, so more the force, or more an object immersed in a liquid, so more will be the liquid displaced in upward direction. So definition states that when a body is partially or wholly immersed in a liquid, it experiences an upthrust which is equal to the weight of the liquid displaced by it. So what amount of loss of weight it takes place, same amount of water will be displaced in upward direction. Like for example, let us consider one beaker. This is the water level. A stone of 5 kg is immersed in this liquid. When it is immersed, it seems that the weight has decreased. The weight became 3 kg. So what is the loss of weight? That is 5 minus 3, 2 kg. So 2 kg of water will be displaced up. That means 2 kg of water will rise up. So this was the simple explanation of Archimedes principle. So when a body is partially or wholly immersed in a liquid, it experiences an upthrust which is equal to the weight of the liquid displaced by it. Now you see, different densities exert different upthrust. Two beaker, one is containing mercury and one is containing water. So in case of mercury, it will exert more upthrust. In case of water, if we take same volume of mercury and water, the water will exert less upthrust. So more the density, more will be the upthrust. Similarly, you will experience a less weight if you are standing on the mercury, but in case of water, you will feel more weight as compared to that of mercury. Or you can say, when an iron nail is dipped in water, it will sink inside, but when the same iron nail, when it is kept on the mercury, it will float, because mercury is more denser than that of water. Next topic we have relative density. So it is the density of substance to that of density of water at 4 degrees Celsius. Density, we know it is mass by volume, but when I say relative density of a substance, so relative density of a substance is calculated by density of substance first. First we will calculate mass and its volume, then we will get the density of the substance, then the density of water at 4 degrees Celsius, that is 1000 kg per meter cube, right? So when we compare the density of one substance with the density of water at 4 degrees Celsius, so that one is called relative density of a substance. So you see the formula, density of a substance can be mass by volume. Similarly, density of water at 4 degrees Celsius is mass of water at 4 degrees Celsius by volume of water. As the volume of substance and volume of water remain same, so both gets cancelled. So we'll get here mass of the substance by mass of water at 4 degrees Celsius. So this is the another formula. Okay, so density of substance to the density of water at 4 degrees Celsius we can write, or we can write mass of the substance by mass of the water at 4 degrees Celsius. Both means same. So 1 gram per centimeter cube is 1000 kg per meter cube. So the density of water at 4 degrees Celsius, we have to take in our numerical this value, right? If it is in gram per centimeter cube, that is 1 gram per centimeter cube. But if you are expressing in terms of kg per meter cube, you have to write 1000 kg per meter cube. There is one experiment you see. So there is one beaker. Beaker is containing water or any other liquid. Let us consider water here. Now a string is tied with one stone, and that stone is dipped inside the vessel. So before immersing, the weight of the solid in air was W1, and when it is immersed in the liquid, the weight became W2. Definitely when an object is immersed in the vessel, its weight will decrease, so the decreased weight is W1 minus W2. Okay, now relative density of solid. Now we are going to find the relative density of solid. So formula states that weight of the solid in air by apparent loss of weight. That means what is the change on weight. Just now we have seen the weight of the solid was W1 and change of weight was W1 minus W2. So therefore relative density stands by this equation, that is W1 by W1 minus W2. Okay, this is how we find the relative density of any solid. W1 by W1 minus W2. So you see a numerical, these numericals are based on the topics just now I have explained. A body weighs 200 gram of force in air and 190 gram of force when completely immersed in water. So first we have to note down what is the weight in air, that is 200 gram of force. Weight in water is 190 gram of force. When that object is immersed in water, what will be the loss of weight? That is 10 gram of force, that is 200 minus 190. So 10 gram of force is the loss in weight. So whatever will be the loss in weight, that will be the upthrust. So what is the upthrust? 10 gram of force. Okay, so how much there will be a loss in weight of that object, so that much upthrust will be exerted in upward direction according to Archimedes principle. So in Archimedes principle, it has been seen that more heavier the object you are immersing in a liquid, so more will be the less in weight of that object, and water will be displacing in upward direction. So there is one more question. So in that question it was saying that the relative density of lead is 11.4. What is the density of that lead? Okay, so we need to calculate the density of lead. We know the formula, relative density of lead equals to density of lead by density of water. So in the question, relative density of lead is given 11.4, and we know density of water at 4 degrees Celsius is 1000 kg per meter cube. Now if you cross multiply, that is 11.4 into 1000, will get 11,400 kg per meter cube. So therefore the density of lead is 11,400 kg per meter cube. Next question we have, a solid is found to weigh 0.08 kgf in air and has a volume of 2.4 into 10 to the power minus 5 meter cube. Okay, so you see mass is also given and volume is also given here. Find its apparent weight in copper sulfate solution, that is CuSO4, of density 1250 kg per meter cube. So weight of solid in air is 0.08 kgf. Volume of copper sulfate is also given in the question, that is 2.4 into 10 to the power minus 5 meter cube, and density is also given. So we need to find first mass of copper sulfate, because we know density equals to mass by volume. So mass can be written as density into volume. So density is given, you see, 1250, and volume is also given 2.4 into 10 to the power minus 5. So once you get a mass, right? So weight of copper sulfate solution displaced. So how much copper sulfate solution has displaced here? That is 0.03 kgf. Now the apparent weight of body in copper sulfate solution. So initially the solid was 0.08 kgf in air, and the weight of copper sulfate is 0.03. So what is the change in weight? That is 0.08 minus 0.03, that is 0.05 kgf. Okay, so in this question we were finding the change in weight in copper sulfate solution. So the object mass in air it is given. So in this question, as volume of copper sulfate and density is given, so from here we will calculate its mass, right? So after calculation of mass, we will subtract the weight of that object in solid to that weight of the copper sulfate, then we will get the change in weight. A body weighs 20 gram of force in air and 18 gram of force in water. Calculate the relative density of the body. So weight of the body is 20 kgf and change in weight is 20 minus 18, that is 20 by 2, that is 10, right? Relative density has no unit, it is a dimensionless quantity. Similar type of example we see here. So weight of a metal in air, So when the object was in air, so weight of that metal was 100 plus 20, that is 120 kgf, right? You see this metal, so 100 gram and 20 gram, that means two objects are there. So in air it was 120 kgf. Weight of the metal in water. Now when same object, when it is being immersed in water, it is weighing 105 gram of force. So the change in weight of that object in water is 120 minus 105, that is 15 gram of force, right? So relative density states that weight of metal in air. So in metal in air it was 120 gram, and here in water it has reduced to 15. So therefore the relative density of the metal is 120 divided by 15, that is 8, right? So these are the few numericals which we have discussed on based upon relative density, or relative density of a solid, relative density of liquid. So these numericals you need to write in your exercise book, and these topics you have to go through in your textbook nicely, right? Just I have shown you which topics you have to focus more or less. All the topics I have touched here, so you don't have to go much detail here. So you'll go for the definition, you will go for the formula and SI unit and CGS unit related to its examples, right? Behavior of bodies of different densities when put in liquid. So what are the different objects when you put in mercury, what happens when you put in water, what happens. So behavior of different bodies immersed in different densities of liquid, so that one you'll go through. Like a good question every time it has come, like where an iron nail sinks in water whereas a ship floats. Okay, where an iron nail sinks in water but it floats on mercury. So this type of give reason questions you have to learn very nicely. Okay, so this was all about Archimedes principle. So see you in next video. Till then, in this week you need to solve the exercise questions of this chapter. Thank you.